Okay, let's go ahead and look at complex conjugates and division. So the definition of a conjugate is going to be a binomial with the same terms and opposite signs. An example of that would be if we're looking at standard form of a complex number. Remember, this is standard form of a complex number, which means a plus bi. So it's the real number, then the complex or the imaginary number. Excuse me, the imaginary number. So the conjugate would be 6 minus 2i. So you're only changing the sign of the interior. So this whole thing right here is a binomial. Alright, so let's go ahead and determine the conjugate of the complex numbers that are given. So remember, we want standard form. And for some of these, we're going to have to simplify. So let's look at B. I have something to simplify here. So I'm going to have negative 4 minus 5i. And so I can say that the conjugate is going to be negative 4 plus 5i. Okay, right here you're saying that I have 5 minus 7i divided by 3. This right here is the binomial. So the opposite would be 5 plus 7i divided by 3. In this case, we're going to write it in standard form. So we're going to say 0 minus 3i. This is what it equals. And then the conjugate will be 0 plus 3i, which equals 3i. The next one, we want standard form right here. So we're going to rewrite it by saying the square root of 17 minus I. So we're looking for the conjugate of square root of 17 plus I. And in this case, we're saying that there's 0b. So the conjugate is going to be just 8. Still looking at complex conjugates and division. I want to go ahead and just look at fractions altogether. So remember that fractions are a form of division. So you're always going to use PEMDAS to simplify. So in the case of G, I have 5 minus 7 divided by 10. So we're going to say negative 2 divided by 10. That's going to simplify to negative 1/5. And then if we look at H, what we're going to do here is we're going to expand the fraction. Okay, so expanding the fraction means that the denominator goes to each term of the numerator. So to do this, we're now going to say that you have 12 divided by 4 minus 2i divided by 4. Now we're going to simplify. 3 minus 1/2 I, and this is my new simplified fraction. Okay, so it's going to go ahead and take our time with complex division. First thing we need is parentheses, and then to multiply by the conjugate, the numerator and the denominator. Everything in the numerator will be in pink. Everything in the denominator will be a blue. So right here, we're going to distribute. Going to get 27 minus 9i minus 6i plus 2i squared divided by 9 minus 3i plus 3i minus I squared. Then we're going to simplify. Let's say 27 minus 15i plus 2 times negative 1 divided by 9 minus I squared, because these two go away. And I'm going to simplify again. Going to get 27 minus 2 minus 15i divided by 9 minus negative 1 and I'm going to simplify again. Say 25 minus 15i divided by 10. Now I'm going to expand the fraction. So by doing this, I'm saying that that denominator goes to each term of the numerator. So now I have 25 over 10 minus 15i over 10. Right here, again, simplify. And I'm going to have 5 halves minus 3 halves I. And that is my solution. So I'm going to multiply the numerator and the denominator by the conjugate. So when I bring this all together, I'm now going to distribute. So I get 8 plus 2i minus 12i minus 3i squared divided by 16 plus 4i minus 4i minus I squared. Simplify. So I want to remember that I squared equals negative 1. 8 minus 10i minus 3 times negative 1, and 16 minus I squared. Keep on simplifying. 8 plus 3 minus 10i, 16 minus negative 1, all the way up here. I get 11 minus 10I over 16 plus 1, 11 minus 10I over 17. I want to split the fraction or expand it, so I say 11 over 17 minus 10I over 17. And that is the division.